Hello guys, thanks for having us here. My name is Martin. I work on the security aspect of Angular, you could say. So I work at Google and I focus on the security aspects of the framework. And with me here is Raphaël, who's from Google's kick-ass security team, who are looking into how to make all of Google's applications secure. So they have a lot of experience with exploits and all this kind of stuff. We're going to talk about Angular 2 security today. Angular 2 has substantial security features that we developed over the last couple of months, I would say. Raphaël reviewed a lot of it. I was doing more of the coding part. And so information security. Information security is, the definition of it is, it's the practice of defending information from unauthorized access, use, disclosure, disruption, or modification. So fundamentally, we're trying to protect your application's information from attackers who could take over your entire application, who could take over individual user accounts, who could do things in your application that are, against your policies. So an example would be somebody buying stuff on Amazon against the will of a user with a user's account, right? Breaching into their account. And I have an interesting picture. I think this is the mandatory picture if you're showing anything about security. So this is a really nice chain, and you can imagine this as being your application's encryption, or your user database, or your HMAC signing of application messages, this kind of stuff. And if you look carefully, you see the plastic, right? The little plastic holding it together. And so the important thing here is, even if you have a great security story in some parts of your application, the weakest link is the problem that people are going to find and exploit. And just hoping that nobody finds your weakest link is not a strategy. It doesn't work. So in our experience, cross-site scripting, which is the main topic that we're going to talk about, is a very weak link. It's very easy to get it wrong. It's very easy to exploit. It's very easy for attackers to find cross-site scripting issues, damn it, in your application. And so what you will end up with is a security system, if you're not careful. You will end up with a security system which is a really nice barrier, so a really nice, well-built barrier, and then everybody just drives around it, right? So everybody just takes the easy way around your security measures. And so we're going to talk about how to prevent this from happening. So same origin policy. Essentially, the web security model means that a website, evil.com, can't access the data of mysite.com. Right? So if you think about it, if you have your website and a user navigates to evil.com, which is apparently the one website where everything bad happens, it's the common example. So evil.com, and now if the evil.com website was able to do actions or interact with the data from your original website, so imagine Amazon.com or your bank's website or something like that, then user data will be lost and actions can be taken by an attacker. And so that's the scenario that we mostly want to protect against on the web. There's multiple attack vectors that are common and that are also protected against in AngularJS. There's cross-site request forgery, cross-site script inclusion, and cross-site scripting. The first two are, I would say, relatively easy to mitigate. AngularJS has built-in support to avoid these issues on the HTTP layer mostly. So we're not going to talk about those. They're documented in our security docs, and you can just take a look. You should protect your application against them, but it's usually not quite as hard as cross-site scripting. Cross-site scripting itself is the major issue. It's very common, and it's also the core of this problem that you run somebody's code in your context of your application. So a script crosses the site boundary and then gets evaluated, and that's the main thing we're going to talk about in this talk. We're not talking about checking your user's password or anything like that. So every application has application level security, like this user can share this document with this other user, but another user might not, like this kind of application level business process security. We're not going to talk about that. So that's an exercise for you guys to get that right. But we're mostly talking about the cross-site scripting aspect. And so I'm going to hand over to Raphaël to explain cross-site scripting in detail.
So hi everyone. A really simple way to think of XSS is simply it's adversarial controlled scripts that run on your origin. So the simplest way to write one of these bugs is to concatenate strings to get HTML. The first example there with PHP that we all wrote at some point. Oh, sorry. Here, if I control the username, then I can execute arbitrary scripts. If my username is a script tag, then it will just be included in the markup and run. From there, this script runs on your origin, so I can get your cookies and send them through an image tag, for instance. You don't need PHP for that. That works with printf. You can also do it with pure JavaScript on the client side. So that's the second example. It works exactly the same way. These two were HTML. You can also do it with URLs. Typically, the first example there will just run on your origin again and can steal your cookies. The second example is a bit more complex. It's, according to spec, data URL will also run on your origin. There's only one browser that does this, it's Firefox. It conforms to spec, so it's not the wrong decision, but it can be quite surprising. And that's part of why XSS is so common and dangerous, because it relies on all the weird things you can find in browsers. So that would be legacy APIs that haven't been removed. That could be new APIs that have just been added. Your data flows are obviously more complex than the two toy examples we gave. Sometimes things can be trusted, not anymore. It varies over time. It's complicated. Since XSS can cause so much damage, like Martin said, bank accounts, you can actually do whatever the user can do on site. You absolutely want to fix those. Why are they so common? So on one side, complexity, and on the other side, because all the basic ways to write HTML to a page will be unsafe. If you do inner HTML, you will have the full power of HTML available to whatever goes into that sink. Same with links, same with HTML concatenation. So one way to think of it is to take an old industrial machine. This is a press, it's really powerful. Problem is that if you put your fingers in it, it won't care. That's the DOM APIs. One thing we want there is to have safety. So safety is the condition of being protected from or unlikely to cause danger, risk, or injury. Which means having a secure application is nice, but not being able to have the bugs in the first place is something we want. In the case of the press we showed before, that would be those types of controllers. To activate the press, you need to actually push two buttons at the same time, which you can do with one single hand, which means if you manage to make the press run, your fingers will not be on it. And that's exactly what we want to do with those web apps. So on to Martin for the implementation.
So this is going back to the initial problem. This is a good example of cross-site scripting, right? So I'm using jQuery here, or not quite jQuery, I think. I should be calling .html, but something close enough. And so essentially I'm getting user bio, the element user bio, I'm taking its inner HTML property, and I'm assigning the user's biography into it. And this looks completely harmless, but of course it means that if the attacker ever managed to control the user biography data element, then he can take over the entire session of the browser, can steal the cookies, can do all kinds of terrible things. And so we should not be doing that. So an easy way to fix that is to not use this code, but rather have an escaping function. So HTML entities here replaces all the magic characters from HTML out of the string. We could probably also replace quotations and apostrophes, but it's not that important. And so we escape user's biography before we assigning it into inner HTML, and so this problem is solved, right? So this code now is safe. Hooray. But the problem with that is that this is one element, and I have to look at this instance, say, okay, this has to be escaped, this has to be done that way. And it turns out if you only get it wrong once, exactly one time is enough, and you have a cross-site scripting issue, and attackers will find it. And so you have to be constantly vigilant to write code like this. And I'm not sure about you guys, but I'm not constantly vigilant. So I will get this wrong all the time. Like every fifth time, I'm probably going to forget some escaping or add some incorrect escaping, add the wrong escaping for the current context, and then I have a cross-site scripting issue, and everything is broken. And so the system, if you build a system like this, where you have to have escaping in the right places, it looks a bit like this, right? So you have all these things in a correct angle and just barely about holding on, but it's very, very fragile. So if you get it wrong anywhere, everything's going to collapse. The poor guy who's sitting there on the left is going to fall down, and users will lose their accounts. Everything will go wrong. So this is not a correct way to fix this because it just doesn't work in the long run. And so a better way of fixing this is essentially creating automatic escaping. So you can look at this template here. Again, it's a similar code. We're adding the user biography into the DOM, but in the template implementation, and this is how it works in Angular 1, it also works in Angular 2, the HTML entities function or some equivalent of it is called on the user biography before putting it into the DOM. So the escaped expression is then appended to the element, but everything is safe here. And the important thing here is that the framework does it automatically for you, right? You, as a user, you don't have to think about it. It just happens automatically, and you cannot get it wrong. So this will actually look like this. So in his free time, Martin writes angle B magic ponies, which is not actually what I do. I write actual ponies. So that's kind of not a very good solution. So a better solution is to have something called sanitize. Right? So you're not escaping the HTML, you're sanitizing the HTML. So this will actually make bold magic ponies and not just angle bracket B ponies. And so the difference between escaping and sanitization here is that escaping disables any special code in the input, and sanitization disables dangerous inputs but keeps most special code. So in our example, we would, for example, strip a script tag from the DOM, but we would keep including a B tag because we know it's harmless. And so Angular 1 and Angular 2 is our topic here, implement a sanitizer that knows HTML, that knows the context of all these elements and correctly sanitizes the input to be harmless but still retain most of the functionality. If you find a way how it's not correct, then please file a bug and you probably get some money from Google. So that's escaping versus sanitization. I mentioned context for escaping, and I'm going to hand over to Raphaël for that.
So, very quickly, I hinted at this in the first examples. We have context. We have HTML, we have CSS, we have script, we have no context, and URL, resource URL. Those are, think of it as types. Those are what your bindings will actually bind. In HTML context, we want to sanitize. In URL context, we want to remove bad URLs and keep the other ones. So HTML, CSS, script, and no security attached are fairly obvious. There's a common mistake there. URL and resource URL are not the same thing. URLs are for links and images, videos, everything that is either displayed on your page or linked to, but isn't expected to run scripts on your origin. A link can run scripts, but it would be in another origin. On the other hand, resource URLs are everything that doesn't fit the URL definition. So that would be script source, for instance. That could be iframes, and that would be template URLs in Angular 1 too. So XSS in relation is strongly tied to context. When you write inner HTML equals username, this means since you use inner HTML, you have the full power of HTML, but you're only expecting something that's just text. That's this difference which causes all the issues. Not yet. So the thing we're doing is actually, instead of letting you touch inner HTML, we'll have HTML bindings, but those will only allow the safe subset of HTML because we assume you don't want XSS. It's usually safe to do so. So how does sanitization escaping actually happen with respect to this context? If you try to bind a link, regular links will work just fine. If you try to bind JavaScript, it's awesome. That's dangerous input, and we won't, it will be turned into unsafe JavaScript input, which won't execute. But on the other hand, if you want to have a link that points to script eval/script, that's weird, but it's a valid link. There's nothing dangerous there, so we'll allow it. On the other hand, if you try to bind HTML, then JavaScript, it's awesome, is fine. It's text, there's no markup there, but scripts, on the other hand, will disable them. And since HTML is a tree, we can do something more interesting. Instead of just removing everything that's dangerous, we can escape what's dangerous and keep the safe parts. So if someday you end up seeing script tags that way, it means you went through the sanitizer and you were trying to do something unsafe. With that.
Yes, thank you. So as I mentioned, Angular 2 is safe by default. So by default, we will sanitize or escape as appropriate for the context in which you're code is running. So all bindings are always sanitized or escaped, or just give errors if we cannot sanitize or escape the binding. And Angular only renders safe content. And I have a whole bunch of annotations on this because there's ways how you can circumvent the system. So if you do interesting or creative code, then something can go wrong. So as soon as you, for example, interact with the DOM directly yourself, then you're no longer safe because you're using the DOM, which is an unsafe API. And so Angular only protects for regular bindings and Angular templates. Now, the problem here is I might actually occasionally want to do something unsafe, right? So sometimes I want to include a YouTube video, which is an iframe, or sometimes I want to actually include a piece of JavaScript on my website, which is just really what I have to do here. And the question here is, how do I tell Angular to allow me to do that, right? How do I get this past the security guard at the entrance, so to say? So if we look at this, for example, we might have a biography as before, but then the users might also have a YouTube video that introduces them or something like that. And so in Angular 2, we would say iframe bracket source equals YouTube URL. This is cool, but Angular 2 will actually tell you, hey, what you're doing here is unsafe, because an iframe could contain arbitrary code, an iframe could contain file downloads, an iframe could contain some website that pretends to be your website and gets the user to type their password into it. So including iframes in your page as is dangerous. And so the problem here is that we cannot sanitize this because we don't understand what the iframe actually points to. So Angular 2 cannot protect you from the potential danger. And now the solution here is that we will have to have an escape hatch. We need to be able, as a programmer, to tell Angular, hey, this thing, I checked it myself, this thing is fine. It's not an attacker, this is my code doing the regular thing that it's supposed to do. And so if we write a component in Angular 2, we might have our biography component here. It has a constructor which takes the DOM sanitizer as an injected element. And then as the setter that takes as an input, the component takes as an input a user. And so when the user is set, we actually validate that the YouTube video ID on the user is probably actually a YouTube video ID, or even if not, is probably harmless. So we have this regular expression here that says if the video ID does not only consist of alphanumeric characters, so backslash W and dashes, if that's not the case, then we throw an error, because we know, hey, there's something weird is going on because YouTube IDs only contain of these harmless characters. And in the other case, we actually say sanitizer.bypass security trust resource URL. So what we're doing here is we're telling Angular security mechanism that we've looked at this URL, we know it's safe. We as a programmer guarantee that this URL is safe to include in the web page. So we're bypassing the security mechanism and we're trusting this thing as a resource URL. And there's similar functions for the different contexts that Raphaël has presented. So there's bypass security trust HTML, bypass security trust script, and so on for the different contexts. And if we have this YouTube URL, so if this value, if we bind that into the website, then we actually get the desired results. So the iframe has the correct source after that. And so this is essentially, if we go back to the switch, which you have to press with 2 hands so that you can't get your finger squished, this is equivalent to just propping one of the switches open, right? So this is actually, you're overriding the switch, you're like forcing like a brick on it or something like that, so the switch is always pressed, and now you're grabbing into the machine. So you better know what you're doing, right? So this is the unsafe part. Angular 2 can no longer guarantee that this is safe. And so if you're doing this, you have to do it sometimes, right? But if you're doing it, please be very careful what you're doing there. And so another thing is how and when should we validate our input and how should we do this? And one of the things that people do is they just put a bypass security trust whatever into the place where the value is used. But that's usually, or that can be a problem. If you have an interesting application that has a very long data flow that essentially ends up with the value bar going into this function call here, then it's fine when you write it properly. But it is very difficult over time to establish that all paths that call into this function always validate the value correctly. And so at this point, you're no longer sure, like if over years people change your application and they change the data flows, can we really guarantee that this is always correct? And so our recommendation there is to make sure that we always validate, or we always bypass security, so we make this call as close as possible to the validation logic. So in a larger application, you would probably say, well, I'm fetching the user, I'm fetching it from the database somehow, so I get this user JSON object, and then there I validate that the video ID is correct, and then I actually make the call for bypass security. So as close as possible to the validation always, you make the call, and then when you're sure that the value is actually correct, you wrap it into your regular object and pass it around in your system, and so you can be sure that the validation is very close to the actual validation of the data. And so there's another thing in Angular 2 that is quite different from Angular 1. In Angular 1, so imagine this is an Angular 1 application, and this is on the server side, we're running some templating language. This looks a lot like PHP, but it doesn't have to be PHP. So we have an HTML page, we have a head, which has a script tag for AngularJS, and then we have the body, which is an ng app, and then we have hello, HTML entities username. The interesting thing here is from a PHP perspective, this code is completely correct, right? So we're escaping any HTML in the username. So if there was a script tag, for example, in the username or some other evil thing, then we would correctly escape it and it would be fine. So far, so good. The problem is with Angular 1, if we call the PHP script with an AngularJS expression, so curly curly evil, open close parenthesis, curly curly close, this is a valid AngularJS expression. And PHP or whatever your server-side templating language is could be anything, right? PHP doesn't know how to validate that. PHP doesn't know how to escape that in particular. So PHP would just say, well, you know, just copy that into the page directly because it doesn't look like dangerous HTML at all, which it isn't because it's Angular. But in effect, what you're doing here is another cross-site scripting kind of application attack. So what we're doing here is a template injection in Angular 1. So the attacker, again, is able to, you know, put code into our executing website and with that actually endanger our user. And the fix for that is in Angular 2 to just not have the problem at all. So what we're doing in Angular 2 is we're doing ahead of time compilation, and I'm sure many other speakers here will talk to you about ahead of time compilation more and more. Angular templates are essentially executable code, both for Angular 1 and for Angular 2, so there's no difference there. If you manage to inject a template into your website, so if an attacker manages to get your website to contain an Angular template, then that's the same as script injection or the same as SQL injection. All of these attacks essentially are the same. And the solution to that in Angular 2 is to just not ship the template compiler at all. So in Angular 2, we can use the ahead of time compiler to compile our templates to JavaScript before we even run the application in the browser. And so the browser never sees the template compiler, it never sees any of this code. And so this has a lot of benefits, like making your application smaller and making your application faster to start, and it also gives you static type checking on your templates. So this is good in many, many ways, but one of the ways it is good in is that the security is much better because this Angular template injection attack cannot happen at all. And with that, I'm going to hand it over to Raphaël once more.
Okay, so you listened to that talk, you wrote your app, it follows what we explained until now. How can you make it better? So, first thing is really review your application for security. We gave you a few dangerous functions, so element ref for direct access to the DOM, which might cause bugs with direct DOM access. The bypass security trust task functions are there, you need them at some point, but you should really review their users. And if you can force code review on these or something, do it, because that's really the first thing I will look at if I'm looking for bugs in an application. Also, it happens that Angular itself has bugs or its libraries. So we fix those, we are looking for those, and we sometimes fix before they're public. But please keep them up to date if you can. Otherwise, all this work is for nothing. Finally, now that you know about context, I gave you a few test vectors that you can use in your automated tests or manually. It's always useful to have a user whose name is image source on error alert with his home URL of JavaScript alert and so on. It catches low-hanging stuff, and this is the embarrassing stuff that you don't want to ship with your app. And yeah, that's it. Okay, thanks for your attention. And if you find issues in Angular, you can report them at security@angular.io. And yeah, thanks for your attention.